unyielding face of a rough planet. A rough planet exists as a testament to the universe's capacity for unforgiving extremes, a world where the environment itself is a constant, unyielding force against any semblance of fragility. Its surface, a fractured and tormented skin, speaks of a violent geological history. Towering, jagged mountain ranges claw at a turbulent sky, born from relentless tectonic shifts or colossal impacts that have scarred the planetary crust. Vast, fractured plains stretch between these peaks, perhaps littered with the debris of ancient cataclysms or carved by erosive forces far more potent than those found on gentler worlds. Deep, chasm-like valleys plunge into the planet's interior, their depths shrouded in perpetual shadow, and perhaps venting noxious gases from a restless mantle. Volcanic activity is not a mere event, but a persistent feature, with lava flows carving fiery paths across the landscape, and ash plumes perpetually staining the atmosphere. The very ground underfoot would be unpredictable, prone to tremors and sudden, violent upheavals. The atmosphere of such a planet is a cruel and capricious blanket. It might be incredibly dense, crushing downwards with immense pressure, or terrifyingly thin, offering little protection from the harsh vacuum of space and the relentless bombardment of stellar radiation. Its composition would likely be a toxic brew, perhaps dominated by corrosive gases, or choked with fine abrasive dust, whipped into planet-wide storms by ferocious winds. These winds, unchecked by significant liquid bodies or complex terrain features that could temper their fury, would scour the surface, further eroding the already harsh landscape and carrying fine particulates that abrade anything exposed. The climate on a rough planet is a brutal oscillation between extremes, depending on its proximity to a star, or lack thereof. In the case of a rogue planet, temperatures could swing wildly. Days might be characterized by scorching, unbearable heat that bakes the surface and creates violent thermal updrafts, while nights plunge into an abyssal cold, capable of freezing most known substances solid. Even on a tidally locked world orbiting a star, one hemisphere would be a perpetually searing inferno, while the other remains locked in an eternal, deep freeze, with only a narrow, tempestuous twilight zone offering a slim, violent transition. Precipitation, if it exists, might take the form of corrosive acids, metallic rain, or even a superheated downpour that flash boils upon reaching the surface. Water, the familiar solvent of life, could be absent entirely, locked away as ice in the deepest, coldest pockets, or instantly vaporized by the prevailing temperatures and pressures. The constant environmental stress, from the intense radiation penetrating a thin atmosphere to the violent geological and meteorological events, paints a picture of a world actively hostile to delicate structures and complex life as we understand it. A truly rough and unyielding environment. The unyielding face of a rough planet. A rough planet stands as a stark monument to the universe's capacity for unforgiving extremes. A world where the environment itself is not merely a backdrop, but a dominant, constant, and unyielding force against any semblance of fragility. Its surface, a fractured and tormented skin, bears the deep-seated scars of a relentlessly violent geological history. Here, towering, jagged mountain ranges do not merely rise, but claw at a perpetually turbulent sky, born from the immense pressures of non-stop tectonic shifts, the explosive power of supervolcanic eruptions, or the catastrophic impact events that have repeatedly reshaped and fractured the planetary crust. Vast, desolate plains stretch like bruised skin between these brutal peaks, perhaps perpetually shrouded in volcanic ash, littered with the sharp, chaotic debris of ancient cataclysms, or relentlessly carved and sculpted by erosive forces far more potent and abrasive than any found on gentler worlds. Deep, echoing chasm-like valleys plunge into the planet's churning interior, their sunless depths shrouded in perpetual shadow and often venting noxious, superheated gases from a deeply restless and unstable mantle. Volcanic activity is not a mere intermittent event, but a persistent, defining feature of the landscape, with rivers of molten rock carving fiery, destructive paths across the surface and colossal ash plumes perpetually staining the very light that manages to penetrate the atmosphere. The ground underfoot would be a treacherous and unpredictable entity, constantly prone to violent tremors, sudden and dramatic upheavals, and the opening of new, fiery fissures. The atmosphere of such a planet is not a benevolent blanket, but a cruel and capricious shroud. It might be incredibly dense, pressing down upon the surface with immense, crushing pressure capable of flattening conventional structures, or terrifyingly thin, offering negligible protection from the harsh vacuum of surrounding space and the relentless, damaging bombardment of stellar radiation or cosmic rays. Its chemical composition would likely be a profoundly toxic brew, perhaps dominated by corrosive acids that eat away at exposed surfaces, or choked with fine, abrasive dust particles whipped into planet-wide perpetual storms by ferocious, high-velocity winds. These winds, unimpeded by significant liquid bodies that could absorb their energy or complex vegetated terrain features that could temper their fury, would scour the surface with tireless intensity, further eroding the already harsh landscape and carrying fine particulates that abrade anything exposed with the force of a sandblaster. The constant atmospheric churn could also generate colossal, planet-sized storms, swirling vortexes of unimaginable power that dwarf anything seen on more tranquil worlds. The climate on a rough planet is a brutal and often rapidly oscillating display of extremes. Depending on its orbital path and proximity to a star, or its isolated trajectory as a rogue planet adrift in interstellar space, temperatures could swing with terrifying speed and magnitude. Days might be characterized by scorching, unbearable heat that bakes the surface, melts rock, and creates violent thermal updrafts and atmospheric instability, while nights, or the permanently shadowed side of a tidally locked world, would plunge into an abyssal cold capable of freezing most known substances solid, creating vast plains of exotic, brittle ice. Even in a hypothetical twilight zone on a tidally locked planet orbiting a star, the temperature transition would be sharp, violent, and marked by perpetual raging storms born from the clash of extreme thermal gradients. Precipitation, if it exists at all within this hostile climate, might take forms utterly alien and dangerous. Corrosive acids capable of dissolving minerals, metallic rain falls as a molten or solidified hazard, or even a superheated downpour that instantly flash boils upon contact with the blisteringly hot surface. Water, the familiar and essential solvent of life on Earth, could be conspicuously absent entirely, locked away as exotic forms of ice in the deepest, coldest pockets safe from atmospheric stripping, or instantly vaporized and dispersed by the prevailing temperatures and pressures. The constant environmental stress, stemming from the intense, unfiltered radiation penetrating a thin atmosphere, the violent and unpredictable geological activity, and the extreme, often sudden meteorological events, paints a picture of a world actively and relentlessly hostile to delicate structures and complex life as we understand it. A truly rough, unyielding, and unforgiving environment where survival would be a perpetual, brutal struggle against the very fabric of the planet itself.